right, now we're going to sketch a quick graph based on some verbal descriptions. So essentially the information you're going to be given is where the graph's positive, where the graph's negative, where the graph's decreasing, and where the graph's increasing. That actually is enough to give you a sense of some important factors of this graph. So the first thing you're going to do is identify or estimate where the x-intercepts are. Well, if you know certain intervals where it's positive and certain intervals where it's negative, right in between it has to be an x-intercept because that's where it switches from positive to negative, where the y value would be 0. So in this case, they're at -4, -1, and 4. Yeah, and the way you can tell, right? So like you have a positive interval from -infinity to -4. That means everything left of -4 is positive. Well, then between -4 and -1, it's negative. So at exactly -4, it's got to be at 0, right? If it's positive before and negative after. And then it stays negative until -1, and then it's positive from -1 to 4. So that means another x-intercept has to be at -1, and then it stays positive all the way to -4, and then it's negative after 4, and then forever. So another x-intercept at 4. So anywhere where it flips like that, you know there's x-intercepts there. So you can plot those points on the graph, and that'll help you draw it. Identify or estimate turning points. Well, those are going to be based on where it's increasing and decreasing. If it's decreasing everywhere to the left of -2.67, and it's increasing from -2.67 to 2, then that's a turning point. That's where it stops. -2.67 is where it stops decreasing and starts increasing, moving from left to right. And then same thing at 2. It's increasing all the way up to an x value of 2, and then it starts to decrease again. So another inflection point at 2. I would draw a dotted line at anywhere where you can identify where there's going to be a turning point. Evaluate the end behavior. Well, if everything to the left of 4 is positive, then it's got to be increasing forever to the left. And then if everywhere after 4 is negative, then it's got to be decreasing. So you can draw a little arrow there to identify what the graph is doing. And then that's enough to just draw it, right? So it's coming in from a positive angle here, crosses at the x-intercept that we identified. It stops decreasing and starts increasing at that turning point that we identified, crosses through at -1, continues to increase until you get to that turning point that we identified at 2. Then it starts to decrease, crosses through the x-axis at 4, and then will decrease forever at that point. So that's your graph. You're going to try to do the same thing here. So pause it and then come back, and then I'll talk you through each of the steps. So try as much as you can get, and then we'll compare answers. All right, so the first things we identified were the x-intercepts, right? So everywhere I could identify where it was flipping from positive to negative. So it appeared to be negative all the way up to -2, and then it flipped to positive, so x-intercept at -2. Then it remained positive until -1, and then it flipped back to negative, so x-intercept at -1. And it remained negative until 1, so x-intercept at 1, and then it remained positive until 2, so x-intercept at 2, and then it went on forever. So that was the last. So there's 4 x-intercepts at -2, -1, 1, and 2. Then I identified the inflection points where it stopped increasing and started decreasing, or vice versa. So it was increasing up to -1.5, and then it started decreasing. And then it remained decreasing until 0. So I have another line here at 0. And then it remained increasing until 1.5. So I have another line at 1.5, and then it went forever. Or then it remained decreasing forever. The end behaviors I was able to identify because it was negative forever up until -2, so it had to be decreasing, moving to the left, and then same with moving to the right. Once you get past 2, it decreases. It stays negative forever, so it's decreasing forever. Um, all right, so that's what the graph should look like. Let's move on to example 5.